Next concept, capacitance of a parallel plate capacitor. Very important 3-mark question for the board exam. Arrive the expression for capacitance of parallel plate capacitor for the 3 marks, or write the expression for capacitance of parallel plate capacitor and hence explain the terms for a 2-mark question, or in a 1-mark question, what are the factors affecting the capacitance of parallel plate capacitors. Therefore, the very important topic for the board exam, expression for capacitance of parallel plate capacitors. Already we have discussed about the capacitors. Capacitor is a system or a device consisting of 2 conductors separated by an insulated medium, and it can store the large amount of the charge carrier, which means if you are given the charge to any one of the conductor, it can store the large amount of charge carriers. Therefore, consider the 2 conductors A and B with the charge plus Q and minus Q separated by the small distance is known to be D. Therefore, the 2 conductor is having the area that is expressed by the term A, and V be the potential difference between the plates. That V is because of, as I earlier discussed, now basically discussed during the process of charging, the positive charge is removed from the negatively charged conductors against the force of attraction, and it is situated over the positively charged conductor against the force of repulsion. Work is done, and that work is stored as a potential. The 2 conductors having the different potential, it means that that potential is considered as a potential difference. Therefore, consider the 2 conductors A and B separated by a distance, separated by an insulated medium with a distance D. Therefore, let A be the area of each plate. What about A be the? Let A be the, capital A be the area of the each plate. V be the potential difference across the plates. The next term Q is the charge on each plate. The next one, sigma be the surface charge density. We know that surface charge density sigma is equal to charge given per unit area. Therefore, sigma is equal to Q divided by A. This is all about the explanations about the diagram. Is it clear? As a basic assumption, we are taken by 2 conductors. The 2 conductors having the same shape and size, separated by an insulated medium. Each conductor is having the same area of cross section A, and it is placed by the charge Q, and it is situated by the charge Q with the surface charge density is known to be sigma. Thus, it is having the potential difference is known as a V. This is the basic explanation about the diagram. Now, in the outer region of the 2 plates, the electric field is 0, the very important one. In the outer region of the 2 plates, the electric field is 0. Suppose if you have taken the first conductor, that is known to be A. Here it is A is known as a conductor A. It is not area of cross section. Area of cross section in general is expressed by A itself. Here it is A and B are the 2 conductors. If you have taken the conductor A, there is a presence of the positively charged conductor, which means that because of that the electric field lines are radially outwards because of the conductor E. The conductor B is having the negative charge carrier. Because of that the electric field lines are radially inwards. Thus it means that whether the number of electric field lines that are entering into that area is equal to, it's not a condition. If the number of electric field lines that are entering into the area is equal to number of electric field lines leaving from that area. ಎಷ್ಟು electric field lines ಗಳು A ನ ಮೇಲೆ ಎಂಟರ್ ಆಗ್ತಾ ಇದೆ, B ನ ಮೇಲೆ ಎಂಟರ್ ಆಗ್ತಾ ಇದೆ, ಅಷ್ಟೇ field lines ಗಳು A ಇಂದ ಏನಾಗ್ತದೆ ಕೇಳಿದ್ರೆ ಲೀವ್ ಆಗ್ತಾ ಇದೆ. Or the one more reason, the 2 conductors are separated by the air medium. In an air medium, in general the electric field is equal to 0. ಇದರ ಸುತ್ತ air medium ಇರುವಂತಾಗಿ ಇಲ್ಲಿರುವಂತ electric field, ಇನ್ನರ್ ರೀಜನ್ ಇರುವಂತ electric field ಈ ಔಟರ್ ರೀಜನ್ ಗೆ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗುದಿಲ್ಲ. ಹಾಗಾಗಿ ಏನಾಗ್ತದೆ ಕೇಳಿದ್ರೆ the electric field is 0. But the basic assumption ಏನು ಕೇಳಿದರೆ ಅಥವಾ ನಾವು ಹೇಗೆ ತಗೊಳ್ತೇವೆ ಕೇಳಿದರೆ, the electric field lines that are entering into the plates is equal to the number of electric field lines leaving that from says or the leaving from their plates. Therefore, what about the outer region? ಆದರೆ ಕಂಡಕ್ಟರ್ ನ ಸುತ್ತ electric field ಏನಾಗಿರ್ತದೆ ಕೇಳಿದರೆ 0. Therefore, in outer region of the 2 plates the electric field is 0. The next one, the electric field in between the 2 plates is given by electric field between the 2 plates or electric field between the plates in between the plate is given by E is equal to sigma divided by 2 epsilon naught plus sigma divided by 2 epsilon naught. ಯಾಕೆ ಹೀಗೆ ಬರೆದಿರಬಹುದು? ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಫಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಥವಾ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ನ ಅಸಂಪ್ಷನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಇನ್ಫೈನೈಟ್ ಪ್ಲೇನ್ ಶೀಟ್ ಆಲ್ರೆಡಿ ನೀವು ಪ್ರೂವ್ ಮಾಡಿದ್ದೀರಿ ಬೈ ಯೂಸಿಂಗ್ ಎನ್ ಗಾಸ್ ಥಿಯರಮ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಇನ್ಫೈನೈಟ್ ಪ್ಲೇನ್ ಶೀಟ್, ಯಾವುದೋ ಒಂದು ಪ್ಲೇನ್ ಶೀಟಿಗೆ ಒಂದು ಪ್ಲೇನ್ ಶೀಟನ್ನು ತಗೊಂಡು ನೋಡಿ, ಒಂದು ಪ್ಲೇನ್ ಶೀಟನ್ನು ತೊಗೊಂಡು ಒಂದು ಚಾರ್ಜನ್ನು ಪ್ಲೇಸ್ ಮಾಡಿ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಗಾಸ್ ಥಿಯರಮ್, ಒಂದು ಸಿಲಿಂಡ್ರಿಕಲ್ ಗಾಸ್ ಥಿಯರಮನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಅಟ್ ದ ಎಂಡಿಗೆ ನೀವು ಒಂದು ಇಕ್ವೇಷನನ್ನು ಪ್ರೂವ್ ಮಾಡಿದ್ದೀರಿ. E is equal to sigma divided by 2 epsilon naught is because of the positive charge carrier. ಇಲ್ಲಿ ನೀವು ಪ್ರೂವ್ ಮಾಡಿರುವಂಥದ್ದು. ಸಪೋಸ್ ನಾನು ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್ ಪ್ಲೇಟ್ ತಗೊಂಡ್ರು ಸಹ ದಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಸಿಗ್ಮಾ ಡಿವೈಡ್ ಬೈ 2 epsilon naught ಬಿಕಾಸ್ ಆಫ್ ದ 2 potential or the 2 charge carriers. Because of the 2 potential or the 2 charge carriers, the electric field between the inner regions E is equal to sigma divided by 2 epsilon naught. ಈ ಎಕ್ಸ್ಪ್ರೆಷನನ್ನು ನೀವು ಎಲ್ಲಿಂದ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು ಕೇಳಿದರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಇನ್ಫೈನೈಟ್ ಪ್ಲೇನ್ ಶೀಟ್ ಬೈ ಯೂಸಿಂಗ್ ಗಾಸ್ ಥಿಯರಮ್ ಫಾರ್ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಸಿಗ್ಮಾ ಡಿವೈಡ್ ಬೈ 2 epsilon naught ಪ್ಲಸ್ ಸಿಗ್ಮಾ ಡಿವೈಡ್ ಬೈ 2 epsilon naught. ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಬರಲಿಕ್ಕಿಲ್ಲ. The resultant electric field, it is the sum of electric field because of the positive potential as well as the negative potential. ಇಲ್ಲಿ ಮೈನಸ್ ಅಂತ ಬರೆಯೋದಲ್ಲ, ಚಾರ್ಜ್ ನೆಗೆಟಿವ್ ಇದೆ ಸರ್, ಪೊಟೆನ್ಷಿಯಲ್ ನೆಗೆಟಿವ್ ಅಂತ ಮೀನಿಂಗ್ ಅಲ್ಲ. ಇಲ್ಲಿ ರೀಸನ್ ಏನು ಕೇಳಿದರೆ ದ ರಿಸಲ್ಟೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ನಾವು ರಿಸಲ್ಟೆಂಟ್ ಅಂತ ಬರೆಯುವಾಗ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡುವಂಥ ಸಿಂಬಲ್ ಏನಾಗಿರ್ತದೆ ಕೇಳಿದರೆ ದ್ಯಾಟ್ ವಿಲ್ ಬಿ ಪಾಸಿಟಿವ್. ದರ್ ಫಾರ್ E is equal to sigma divided by 2 epsilon naught is because of the positive charge carriers or the positive potential is on the plate A. Plus sigma divided by 2 epsilon naught is the term or the expression is because of the plate A with the potential is called as a negative, but the resultant electric field ನಮಗೆ sum of electric field ಸಿಗ್ತದೆ in between the plates. ಹಾಗಾಗಿ ನಾನು ಏನು ಮಾಡಿದ್ದೇನೆ ಕೇಳಿದರೆ ಪ್ಲಸ್ ಆಗಿ ಬರೆದಿದ್ದೇನೆ. therefore sigma divided by 2 epsilon naught plus sigma divided by 2 epsilon naught that is equal to, by taking the LCM, 2 epsilon naught is common. therefore 2 sigma divided by 2 epsilon naught, 2 sigma divided by 4 epsilon naught ಆಗೋದಿಲ್ಲ. 2 epsilon naught ಅನ್ನುವಂಥ ಟರ್ಮ್ ಏನಾಗಿರ್ತದೆ ಕೇಳಿದರೆ ಇಲ್ಲಿ ಕಾಮನ್ ಆಗಿರ್ತದೆ, 4 epsilon naught ಅಂತ ಬರೆಯೋದಲ್ಲ. ಸರಿಯಾ? ಹಾಗಾದರೆ ಏನಾಯಿತು ಕೇಳಿದರೆ LCMನ ಮೆಥಡಲ್ಲಿ ಏನಾಯಿತು ಕೇಳಿದರೆ ಇಕ್ವೇಷನನ್ನು ಹೇಗೆ ಬರೆದಿದ್ದೇವೆ, 2 sigma times of divided by 2 epsilon naught. therefore what about the term 2 gets cancelled out. therefore E is equal to sigma divided by epsilon naught is the expression. We know that. What is sigma? Sigma will be surface charge density. What is the expression for surface charge density over the surface? The charge given to the area charge per unit area is considered as a surface charge density. Therefore E is equal to sigma divided by epsilon naught. We know that the expression for sigma, what is sigma is equal to? Sigma is equal to Q by A. Sigma the place ಅಲ್ಲಿ ನಾನು Q by A ಅಂತ ಬರೆದ್ರೆ the rest of the term is known to be epsilon naught, that will be written as usual. sigma the place ಅಲ್ಲಿ Q by A ನ ಹಾಗೆ ಬರೆದಿದ್ದೇನೆ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಬರೆದಿದ್ದೇನೆ. ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಅನ್ನು ಹೇಗೆ ಬರೆದಿದ್ದೇನೆ ಕೇಳಿದರೆ ಆಸ್ ಯೂಶುವಲ್ ಆಗಿ ಬರೆದಿದ್ದೇನೆ. therefore what about E is equal to, therefore the electric field in between the plates, the electric field in between the plate is expressed by E is equal to Q times or Q divided by epsilon naught times of A. Is it clear? The next one, the continuation, the direction of electric field is from the positive to negative plate, positive to negative plate, and the electric field is uniform. The direction of the electric field from positive to the negative plate, the electric field is uniform. ಈ ಪ್ಲಸ್ ಇಂದ ನೆಗೆಟಿವ್ಗೆ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನು ನಾವು ಏನು ಬರೆದಿದ್ದೇವೆ, ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಫ್ರಮ್ ಪಾಸಿಟಿವ್ ಟು ನೆಗೆಟಿವ್ ಆ್ಯಂಡ್ ದಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಯೂನಿಫಾರ್ಮ್. ಫಾರ್ ದಟ್ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವಿ ಆರ್ ರಿಟನ್ ಬೈ ಒನ್ ಟರ್ಮ್. That term is called as V is equal to E times of D, where V is called as a potential difference between the plates or the conductors. E is known to be electric field. D is known to be distance between the plates. What about E is known to be distance between the plates? ಇದೇ ಎಕ್ಸ್ಪ್ರೆಷನ್ ನಾವು ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತೇವೆ. That chapter is known to be current electricity. In that chapter we are taken by one conductors. In general there is a presence of large number of free electrons. When we are applying the potential, external potential by using a battery, there is a generations of the electric field. Therefore the direction of the electric field is like this, but these free electrons that are drifted in the opposite direction because of that external potential. ಮುಂದೆ ಬರ್ತದೆ, ಜಸ್ಟ್ ನಾನು ಬೇಸಿಕ್ ಅಸಂಪ್ಷನ್ ಅನ್ನು ಹೇಳಿಬಿಡ್ತೇನೆ. Let L be the length of the conductors. Therefore the conductor in which we are applied by the external potential, ಕಂಡಕ್ಟರ್ನ ಎರಡು ಟರ್ಮಿಗೆ ನಾವು ಏನು ಮಾಡಿದ್ದೇವೆ ಕೇಳಿದರೆ ಬ್ಯಾಟ್ರಿನ ಕನೆಕ್ಟ್ ಮಾಡಿ ಪೊಟೆನ್ಷಿಯಲನ್ನು ಕೊಟ್ಟಿದ್ದೇವೆ. Thus inside the conductor there is a presence of electric field. Therefore that electric field is expressed by E is equal to, ಆದರೆ electric field ಅನ್ನು ಹೇಗೆ ಮೆಷರ್ ಮಾಡ್ತಾನೆ ಕೇಳಿದರೆ E is equal to, we are done by the term is known as V divided by L. As what about that V is known to be V is nothing but potential, and that potential is given by by a battery. ಅದರ ಪೊಟೆನ್ಷಿಯಲ್ ಎಲ್ಲಿಂದ ಕೊಟ್ಟಿದ್ದೇವೆ ಕೇಳಿದರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಸಪ್ಲೈ ಆಗಿ ಯೂಸ್ ಮಾಡಿರುವಂಥ ಬ್ಯಾಟ್ರಿಯಿಂದಾಗಿ. Therefore E is equal to V by L. What about L is known to be is the length of the conductors. ಈ ಎಲ್ಲನ ನಾನು ಹೇಗೆ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಾನೆ ಕೇಳಿದರೆ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಪ್ಲೇಟ್ಸ್ ಆದ್ದರಿಂದಾಗಿ D ಆಗಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೇನೆ. Therefore E is equal to V by D. Electric field inside the conductor is because of an external potential. E is equal to V by D. Therefore what about V is equal to, by rearranging the equation, V is equal to, we get it as V is equal to E times of D. ಅದೇ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನು ಬರೆದಿರುವಂಥದ್ದು ಇಲ್ಲಿ ನೋಡಿ. that you studied in the next chapter. ಈ ಕಾನ್ಸೆಪ್ಟ್ ಪುನಃ ನಿಮಗೆ ಬರ್ತದೆ ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರಲ್ಲಿ ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯಲ್ಲಿ. ಜಸ್ಟ್ ಬೇಸಿಕ್ ಅಸಂಪ್ಷನ್ ಅನ್ನು ಕನ್ಸಿಡರೇಷನ್ ಅನ್ನು ಕೇಳಿದರೆ, ಫಾರ್ ಎ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ದ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇಲ್ಲಿ ಆಗಿರ್ಬೋದು. ಫಾರ್ ಎ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ದ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ V is equal to, V is the potential difference, V is equal to E times of D. Therefore V is equal to, what is the expression for E? That I already proved. What is the term E? E will be Q divided by epsilon naught A. That I substituted here. ನಮಗೆ ಇಲ್ಲಿ ಸಿಕ್ಕಿದಂಥ ವ್ಯಾಲ್ಯೂನ E ಏನಿದೆ ಅದನ್ನು ನಾವು ಇಲ್ಲಿ ಇಕ್ವೇಷನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾನೆ. ಹಾಗಾದರೆ ಇಕ್ವೇಷನ್ ಏನಾಗ್ತದೆ? V is equal to, in the place of E will be Q divided by epsilon naught times of A. ನೋಡಿ, ಇದಿಷ್ಟು ಟರ್ಮ್ ಏನಿದೆ Q divided by epsilon naught times of A ಅನ್ನುವಂಥ ಟರ್ಮ್ ಏನಿದೆ is because of the electric field E. ಟೈಮ್ಸ್ ದಟ್ ಟೈಮ್ಸ್ ಇಸ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ದ ಟರ್ಮ್ ಇಸ್ ನೋನ್ ಆಸ್, ಅದರ ಜೊತೆಗೆ ಮಲ್ಟಿಪ್ಲೈ ಆಗಿರುವಂಥ ಟರ್ಮ್ ಯಾವುದು? ದಟ್ ಇಸ್ ನೋನ್ ಟು ಬಿ ಡಿ. Therefore V is equal to E times of D. Therefore V is equal to, the value of E will be Q divided by epsilon naught times of A, that I substituted here, times of D. Therefore what about the potential difference? V is equal to Q times of D divided by epsilon naught times of A, that is QD divided by epsilon naught A. Is it clear? Now according to the general expression capacitance of parallel plate capacitor, just ಈಗ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೇನೆ ಲಾಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟಲ್ಲಿ, C is equal to Q by is the general expression. C is as usual equals Q is as usual, but the term V is replaced by this equation. What is V? V is nothing but Q D divided by epsilon naught A. Therefore the term QQ gets cancelled out. 1 by D divided by epsilon naught A, 1 whole divided by D divided by epsilon naught A. Denominator of the denominator is multiplied over the numerator. Therefore C is equal to epsilon naught times A divided by D. Hence the proof. This is actual proof. The capacitance of parallel plate capacitor is expressed by C is equal to, capacitance of parallel plate capacitor C is equal to epsilon naught times of A divided by D. Therefore capacitance of parallel plate capacitor is directly proportional to, ಮಕ್ಕಳ A ಅಂತ ಹೇಳಿದ್ರೆ ಏನು? A is nothing but area of the plates. Therefore capacitance of parallel plate capacitors is directly proportional to the area of the plates or area of each plate. Capacitance of capacitor is inversely proportional to the distance between the two plates or the two conductors. Therefore the very important one mark question, 3 mark, ಇಲ್ಲೇ ತನಕ ಪ್ರೂವ್ ಮಾಡ್ತೀರಿ 3 ಮಾರ್ಕಿಗೆ. ಅರೈವ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಆಫ್ ಪ್ಯಾರಲಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟರ್ಸ್, ಇಲ್ಲಿ ತನಕ ಪ್ರೂವ್ ಮಾಡಬೇಕು. 3 ಮಾರ್ಕಿಗೆ ಕೇಳಿದರೆ ಅಥವಾ 3 ಮಾರ್ಕಿಗೆ ಕೇಳಿದರೆ, ಒಂದು ವೇಳೆ 2 ಮಾರ್ಕ್ಸ್ಗೆ ಕೇಳಿದರೆ write the expression for capacitance of parallel plate capacitor, hence explain the terms. ಇಕ್ವೇಷನ್ ನೀವು ಪ್ರೂವ್ ಮಾಡಬೇಕಂತ ಇಲ್ಲ, ಜಸ್ಟ್ write the expression ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಅರೈವ್ ಅಂತ ಕೇಳಲಿಲ್ಲ ಅಥವಾ ಡಿರೈವ್ ಅಂತ ಕೇಳಲಿಲ್ಲ, write the expression. ಜಸ್ಟ್ ಈ ಲಾಸ್ಟ್ ಇಕ್ವೇಷನ್ ಅನ್ನು ನೀವು ಬರೀಬೇಕು. ವಾಟ್ ಇಸ್ ದ ಇಕ್ವೇಷನ್? C is equal to epsilon naught times A divided by D. ಟರ್ಮ್ ಅನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು. ವೇರ್ C is equal to capacitance of capacitor, epsilon naught is equal to permittivity in free space, A is equal to area of each plate, D is equal to distance between the two plates. One mark important question. What are the factors affecting the capacitance of parallel plate capacitors? Yes, what are the factors? The one factor will be area of the plates, equation alle ide. The one more factor will be distance between the plates. Epsilon naught is constant. Along with that, in the next session I will discuss expression for parallel plate capacitor in case of a dielectric. Therefore capacitance of capacitor depends on the factors. In that, the first one area of the plate, that is expressed by A. The second one separation between the plates, that is expressed by the term is known to be small d. The next one nature of the dielectric medium used between the plates. ಎರಡು ಪ್ಲೇಟ್ ನಡುವೆ ನಾನು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೇನೆ, that is expressed by the term is known as K. Here we are not written by the term K. ಇಲ್ಲಿ ನಾನು ಟರ್ಮ್ K ಅನ್ನುವಂಥ ಟರ್ಮ್ ಅನ್ನು ಬರಲಿಲ್ಲ, ದ್ಯಾಟ್ ಐ ವಿಲ್ ಪ್ರೂವ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಇದನ್ನು ಪ್ರೂವ್ ಮಾಡ್ತಾನೆ, ಕೆ ಎಲ್ಲಿಂದ ಬಂತು ಅನ್ನುವಂಥದ್ದನ್ನು. ಪುನಃ ಇನ್ನೊಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಇದೆ ಇದೇ ಟಾಪಿಕ್ನ ಮೇಲೆ. ದರ್ಫೋರ್ ದ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್, ವಾಟ್ ಆರ್ ದ ಫ್ಯಾಕ್ಟರ್ಸ್ ಎಫೆಕ್ಟಿಂಗ್ 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ಬೋದು, ಮೆನ್ಷನ್ ಎನಿ, ಅಥವಾ 2 ಮಾರ್ಕಿಗೆ ಕೇಳ್ಬೋದು, ಮೆನ್ಷನ್ ಎನಿ 1 ಆರ್ ಮೆನ್ಷನ್ ಎನಿ 2. ದ ಫ್ಯಾಕ್ಟರ್ಸ್ ಎಫೆಕ್ಟಿಂಗ್ ದಿ ಕೆಪಾಸಿಟೆನ್ಸ್ ಆಫ್ ಕೆಪಾಸಿಟರ್, ವಾಟ್ ಆರ್ ದ ಫ್ಯಾಕ್ಟರ್ಸ್? ದ ಏರಿಯಾ ಆಫ್ ದ ಪ್ಲೇಟ್ಸ್. The second one, the distance or the separation between the plates. The next one, nature of the dielectric medium used between the plates. Is it clear? Very important concept. Arrive the expression for capacitance of parallel plate capacitors is.